Good afternoon, class. Good afternoon, class. We're looking at the SI unit derivation. Now, in this class, what we're going to be doing is to know how to derive the SI unit of a physical quantity. Are you following? In case you are asked a question in YA, and you are asked, what is the unit of radian? And you have all this list here: kilogram times by meter per meter, times by seconds per seconds, kilogram times by meter per meter per meter, and seconds per seconds per seconds per seconds. Then you have this guy, kilogram, the rest. Are you following? How do you find the SI unit of any physical quantity? The first thing to know is that what are physical quantities? What are physical quantities in units? In physics. In physics, physical quantities are the parameters which we use in measuring a physics. Are you following? For instance, we have area, time, length, velocity, pressure, momentum, work done, force, and so on and so forth. So what we're going to do in this class is to understand how to derive these units from the quantities, the physical quantities. And you cannot study physics anyhow without physical quantities. Are you following? Yeah. From the chapter 1 to the end of the physics note to our textbook, you will find physical quantities here. Are you now? So, what is the meaning of SI unit? SI unit means the standard unit of measurement. What's SI unit again? Standard unit of measurement. Please say it again.
Standard unit of measurement.
Say it again.
The standard unit of measurement.
So, if SI unit is the standard unit of measurement, that means that every measurement you are going to carry out in physics will fall under the SI unit. Are you following that? Yes. Any measurement that is carried out that is not satisfied by the SI unit is not a physics measurement. So, what do we do? What we do is that we're going to bring out all the quantities and the units, and then we do just visualization. For instance, we have the fundamental units. Alright, why I'm saying units is because you must have had the word quantities, fundamental quantities, derived quantities. I'm saying units because we want to derive these things with respect or reference to a specified quantity. So, for the fundamental unit, it is attached to the fundamental quantities. For the fundamental unit, they are attached to the fundamental quantities. Are you clear?
Yes.
Alright. Now, pay attention. If that is so, what are fundamental quantities? These are the right that's successful function. These are basic quantities. Fundamental quantities. These are basic quantities which are independent of other quantities. Meanwhile, the unit also should be defined on the same plane. These are basic units which are independent of other units. When there is quantity, remove it and put units. Are you following that? Fundamental quantities are basic quantities that are independent of other quantities. It is for units. Fundamental units are basic units that are independent of other units. Very simple. You don't need to plan it. Are you following that? Yes. So we go to the fundamental unit. For instance, mass. What unit of mass is? Kg. Mass, kilogram. Then another one. Length. What unit of length? Meter. Another one. Time. What's unit of time? Another one. Current. Electricity.
Ampere.
What's unit of electricity?
Ampere.
ampere. Now, meanwhile, let me look up. Electricity can also be measured in coulombs per second. Have you heard that before? Electricity can also be measured in coulombs per second. Now, let me show you what I mean by that. Let's say we have current. Current is denoted with a letter I. You know that? Now, current is simply change in coulombs over change in time. What is current?
Current is change in time.
What is current?
Current is
Change in coulombs over
change in time.
Now, coulombs is represented in C. Are you there now?
Yes.
Time is represented in what? Seconds. In mathematics. In what? Mathematics. The rule of this is called the rule of negative endless power. It says that if x is to the power of minus 1, it is the same thing as 1 over x. If this x should become 1, it becomes coulombs per seconds. Are you following that? This guy is also equals to this guy. The problem is that this one has been divided, this one has not been divided. So you can say that 1 coulombs per second is equal to 1 ampere. You are correct. 1 coulombs per second is equal to what? 1 ampere. You can also say 10 coulombs per second. 10 coulombs per second is equal to how many ampere? 10 ampere. That means the value ampere is equivalent to the value coulombs per second. In case you see it, which of these is the dimension for electricity? And you're looking for ampere in this seat. And you see coulombs per second. Please click this one. And you know why it can be very funny. They'll do something like this. Watch. Just watch it. The unit for electricity, they'll do like this. A coulombs per second. Are you following that? B coulombs per second. C coulombs per second. What's the answer?
B.
What's the answer? C. The answer is C. The answer is not A. Sorry, the answer is not A because you know in WAEC, if you say C over X is not the same thing as C times by X. Are you following that? Okay, now you can leave it in this one. The next one is B. Notice that B is with this form, but the problem we have is that B is having a negative sign, and it is wrong. This is wrong, this is wrong. So the answer is this guy. Because after the division is done, the S will have a negative sign. So what we have, this is the answer. So if you ask the question, look at the options. Maybe something like this is written. Coulombs per second. That means that D and A is correct. Are you following? Because the equation has not been divided. The formula has not been divided. Now, you can write for me. Write in your note. Fundamental units. Have you seen that now? Have you seen it? Okay, we are. Alright, what's another fundamental quantity?
You mean not frequencies?
No, let's take it small.
Pressure.
I learned about temperature. So temperature. There's measurable Kelvin. Temperature can be measured in Kelvin, in Celsius, and Fahrenheit. In one of the classes, I'll tell you how to convert from Celsius to Fahrenheit, Fahrenheit to Celsius, Kelvin to Fahrenheit. Convert within the period. You will convert it from one to one. Are you following? Now, meanwhile, let's focus on the concept of today. Another one is amount of substance. Amount of what? Substance. And it is called mole. Are you following? The next thing is not 7.
Yeah.
What's your rate of remaining one?
Standard.
Luminous intensity. Which is what? Candela. Which is measured in what? Candela. Yes, candela.
Magnetic flux.
Okay? Now, we want to go to the next thing is the derived unit. Have you got it? These are units that depend on fundamental units. That one is settled. These are units. Let me open up this question. Have you answered this question? Have you answered this? Yes. None of their own. No, leave the question there, one side. These are units that are dependent on the fundamental unit. Let's pick the unit one after the other. Let me start with area. This is area. I said the right units. They are units that are dependent on the fundamental unit. So let's start with area. So what's the unit of area?
Hello,
the formula of the quantity, you can't go to the unit. So what's the unit of what's the formula for area?
Hello,
So it's length times what?
Breadth.
Now listen. You can write that. Write it down. So length is represented using
M. Mass.
Sorry, now look up. Let me teach you before I go. Watch this place. What do you see?
Mass and style.
What do you see?
Mass and style.
Say it again.
Mass and style.
Everybody, say it again.
Mass and style.
Why do I cite you that place? Why I cite you it is because among the fundamental quantity, there is fundamental of fundamental. What do I say?
Fundamental of fundamental.
Now the fundamental of fundamental is mass, length, and time. So that is the basis which you're using to derive other derived quantities and units. Are you following? So every calculation we are doing will based on mass, length, and what? Time. The unit of mass is what? Kilogram. The unit of length is what?
Mass.
Sorry. Unit of length is what?
Meter.
Unit of time is what?
Seconds.
So that is what we are using to derive other small units. Those derive, they are made of those. We're using these class. Meter, mass, kilogram, length, meter, seconds, time to derive every other derived units. Now let's look at area. Area is length and breadth. From here, how can we measure the length? Do we measure length with kilogram?
No, meter.
We measure length with what? Meter. Do we measure breadth with kilogram?
No, seconds.
What do we use to measure breadth? Let me show you. The length is from where I'm standing to the top of the roof. That is length. It's measured in meter. The breadth is from this other side to this other side. It's also measured in meter. They say length times breadth times height. Okay? Length is coming from here to that side. It's also measured in what? Meter. Anything length, breadth, height is measured in what? Meters. So we're going to have breadth is also what? Meter. In indices. In what? In indices. If x is the power of a times by x is the power of b is equal to xa plus b. That is the law of multiplication. Law of what? Multiplication. If I have 2 raised to the power of 2 times by 2 raised to the power of 2, my answer is 2 raised to the power of 2 plus 2. What's the answer? 2 raised to the power of 4. 2 raised to the power of 4 is what? I think calculator
2 times
that should be 16. 2 raised to the power of 4 is 16. Use the calculator. Let me confirm. It should be 16 anyway. 16, correct. Now watch. That's 16. I just want to confirm that. If you have 2 raised to the power of 2 times by 2 raised to the power of 2, which is what you are seeing here. Are you with me? 2 raised to the power of 2 is what? It's 4. 2 raised to the power of 2 is what?
4.
4 times 4 is what? 16. Are you seeing that?
Yes.
So if you have the same base, if you have x and x, 2 and 2, they are the same thing, so it's the same base. But if you have x raised to the power of a times by y raised to the power of b, it is not equal to this stuff. Are you following that? Okay? Now let's go back to physics. Should I clean up now? Should I clean up? Yes. Let me clean up. Let's go back to physics. So what we have here is m times n. M and n are they the same thing? Yes. 1 plus 1. What's the answer?
M2.
So that is why area is measured in meter square. And that's the unit of area. That's why area is measured in what? Meter square. Now, let's deal with volume. Volume is length times breadth times what? Height. And you should remember that. You do. So, which is meter. That is measured in what? Meter. That is measured in what? Meter. So 1 plus 1 plus 1, what's the answer? Meter cube. So volume is always represented in meter cube. Do you know the reason why? Have you seen it now? That's why volume is always in meter cube. Area is always in meter square. Let's deal with this. Let's do which one now? Density. So, what is the formula for density?
Mass over volume.
Mass over volume. Good. So, density is mass over V, volume. What's the formula for volume? What's the formula for mass? V for mass, sorry. Kilogram. Divide. What's it for volume? Meter cube. In mathematics, when you are dividing a value and the index of the denominator, are you following that? Is carrying an index. When that thing comes up, it will become a negative index. It will change. That is in mathematics. Indices is called the rule of negative index power. What do I call it? The rule of negative index. Say it. The rule of what?
Negative index power.
When we have x minus 1, the same thing as 1 over x. So we will apply that one there. So what do we have now? When this thing applies for what will become? Kg, meter, per meter, per meter, per meter. Kilogram, meter, raised to the power of minus 3. That's the unit of density. They can ask you, what is the unit of density? And they will put, this is A, they will put B, they will put C. What's the answer? The answer is A. You follow it now? So, let's move to velocity. What's the next thing now? Velocity. What's the formula for velocity again?
Displacement over time.
Say it well. What's the formula for velocity again?
Change in displacement over change in time.
Displacement over time. So, displacement over what? Time. And this thing is not too bad. What is displacement over time? Now, I want to ask a question. What do you think we can use to represent displacement from all these things?
Length and time.
Displacement is length. Because displacement is the total distance. Displacement is the total length of a body regarding to the final position and the initial position. What do I mean? Let me explain. Let me calm down. Displacement, if you want to define, is the total length of, let me put it in a simple term. Displacement is change in position. What do I call it? Change in position. So let's not pick up English and grammar. Displacement is what? Change in position of a body. That's displacement. Do you understand what displacement is? Change in position of a body. So if you understand that, the change in position is represented with the length. So what do we see? What's the unit of length? Meter. What's the unit of time? So this is what we call meter per second times 1. So this is the unit for velocity. Are you still there? Are you still there? Yes. All right. Let's do for acceleration. Acceleration is change in velocity over change in what?
Time.
What is the formula for unit for change? You know we're using units. I Units Derivations. That's what we are doing. So when we have meter per second minus 1 divide by seconds, please. Minus 1 minus 2. What's that?
Minus 3.
Minus 1 minus 2.
Minus 3.
Let me help you. You are owing somebody 1 level. You are owing 1 level. And then you came to me. You are owing 1 level, which is minus 1. You came to me and borrow another 1 level. How much I owe you? Minus 2. If you follow it, let's not calm down. Let's move on the normal plane. I am owing 1 level. I am owing what? 1 level. I went to borrow another 1 level. You follow it? So minus 1 minus 1 is minus 2. You are owing 10 naira. Went and borrow 10 naira. Owing is minus. Borrow another 10 naira. How much are you owing? Minus 20. Are you following? So we have the minus 1 minus 1 is to give you minus 2. So you will notice that the unit of acceleration is like this. The unit of velocity is like this. Any confusion? What's the confusion? Just ask your question. changing velocity over changing time. Can you find the unit for velocity? You can find it. This is velocity. Displacement over time. Displacement is meter per second. In this diagram becomes a -1. So meter per second. So we carry it. Because acceleration is changing velocity over changing time. Put it here. You see the same thing. The -1 -2. Like -1 -1. What will it be?
-2.
Let's go to another. Let's do for force. Let's do for what? Force. So what's the formula? What's the unit for force?
Mass times acceleration.
Mass times what?
Acceleration.
But let's start with the common unit. The common unit of force is Newton. Common unit of force is what?
Newton.
Newton. Isaac Newton. That's the guy that discovered it. Isaac Newton. Now, in terms of this, okay, we want to use FLT. Are you following? So that mass is equals to force. Sorry, force equals to mass times what?
Acceleration.
So what's the unit for mass? Kilogram. What's the unit for acceleration? This is it. If you don't know it, you better solve it. Where is it?
Mass per
Meter per second. Multiply this thing. What do you have? Kilogram, meter per second. So in the action, what's the unit for force? And you see any of those, okay, this is great. This is the answer. Can you follow it? Is there any confusion? You follow what I'm saying? Now the next thing is momentum. There's what? Momentum. Are you actually right? Should I continue? Okay. Momentum is
Mass
times what?
change in velocity.
No, mass times velocity. Okay? Or change in velocity. Meanwhile, because if there's a change, maybe x2 minus x1, if you change the velocity, you can apply. But we're just going on a straight line. So it's mass times what? Velocity. Are you following? Now, what is the unit for mass?
Kilogram.
Kilogram. What's the unit for velocity? Meter per second, or meter times by seconds raised to the power of what? -1, sorry. So multiply this with what do you have?
Meter per second.
Per second. So that's the answer. The next thing we are going to be looking at is praying. Let's look at praying. Should I be here? Yes. Praying. You know how the Yoruba guys, so we call it praying. It's pressure. Yeah, pressure, not praying. Why I call it praying. So let's look at praying. Which is this guy? So I asked you an illustration. You know the formula for praying.
Force over acceleration.
Force over acceleration. No, force over area. Now let's maybe like two persons, they are fighting. Okay? They are what? Fighting. Now if two persons are fighting, and then let's say you are fighting with someone, and then this guy will use physics to ask you a question. He says, yeah, why are you arguing with what's suppression? Are you following? I want to talk physics. So what's suppression? We are just talking. What is suppression? Are you following? And the other guy at the other end will say, vibration. Vibration is the force of the disturbance acting on the area of my heart. Are you following? Because the person has disturbed you, and then you get to react. You get to what? React. What's suppression? Vibration is the force acting on the area of what? My heart. So pressure is force over what? Now let's use Newton. Let's use what? Newton to find this thing. So force is Newton. Force is what? Newton. So Newton, what's the unit for area? Meter square. Are you following? Meter square, not meter cube. Meter what? Square. That's area. Now notice, if this thing line will hold it up. Newton, meter, let's do the power of -2. This is a unit. This is constant jam pressure. This is. They will put -1. They will put -2. They will put -3. And they will just put this. They will not put anything. Are you following that? Yeah. This is constant. This one is right. This one is always coming out in jam. Are you following that? Now let's look at this. Let's look at this. This is Newton meter. Let's calculate pressure, which is force over area, in terms of meter, length, and time, which is our direct standard. So now we have that force. Have we found force before? Where is the force? Have you seen it now?
Yes. Mass by size.
So this is the unit of force. So we don't have time to begin to derive it again. Let us carry this guy and slot in here. Are you following now?
Yes.
Which is coming from me? Kilogram?
Meter per second minus 2.
Minus 2. Now when divided by area, area is meter to the power of minus 2. Please, 1 minus 2 will give you minus 1. 1 minus 2 will give you what?
Minus 1.
Minus 1 kilogram, meter is power minus 1, and the second is power 2. So can we find the answer for prayer? Is that the answer there? Okay, we have C. Option C is the correct answer. So this one usually comes out in 1 seconds. Are you following me? This one usually comes out in jam setting. This one usually comes out in where?
1 second.
Now, let's move to the next thing. Let's go to work done. Where's my notes? Work done. Should I put it up here? Work done. So what's the formula for work done?
Cross and distance.
Good. Work done is equal to force times what? Distance. What's the unit for force again? Gravity. Let's start with Newton. Let's have it go. Newton. So Newton times by what is distance? Meter. Distance is measured in what? Meter. So the unit for work done is Newton meter. This one is jam setting. You can also have the so Newton meter. That's the unit for work done. But if it's for our hectare, work done is the same thing as force times what? Distance. What's the unit for force there? This is kilogram, meter, and then minus just the power of second just the power of minus 2. When multiplied by distance is represented in meters. Are you following now? When represented by what? Meter. Please indices. This is the same base. 1 plus 1 is what? This is 1. This is 1. And when I have x to the power of a times by x to the power of b, what is equals to x equals to a plus what? B. You still remember that? Yes. So 1 plus 1, what's the answer? Is equals to x to the power of 2 times by seconds minus 2. So this is the unit for work done. This one is correct. This one is also correct. This one is correct. This one is also correct. Are you following?
Yes.
So we go to the other one. The other one. Find a new unit for after work done. What do we have again? Have we finished all the units?
Power.
Let's go to Pro. It's power. It's power. Power. Let's go to power. What's the formula for power?
Energy over time.
Work done over time. Yeah. Work done over time. So now, let's use, have we done work done before?
Yeah.
We did it twice. The first one is Newton meter. Have you? Okay, let's do it like this. So we have Newton meter divided by the seconds. The first thing that only become Newton meter per second. Are you following? You can have it it's still the same thing. Nm minus 1. Still the same. So this is jam setting. Let's do it to my extent. Let's do it. But that doesn't mean that I can't ask the question. It can come out in both of those. Are you following? So let's do another one. In regards to what did you tell me that I said? Power. Yeah, because pressure sounds like power, but it's the same thing. So let's write it down. Power. Power. This is power. It's not pressure, it's power. Okay? Power is the same thing as work done over time taken. Can we find work done? I think this is work done back. Let's put it on. Kilogram, meter is the power of 2, second is the power of minus 2. Is that right? Second. What's the second? What is time? Second. Minus 2 minus 1.
Minus 1.
Minus 2 minus 1.
Minus 3.
Minus 3. Let me explain that again. You are going 2 names. You went and borrow 1 name. How much are you borrowing? So this is correct, and then this is also correct. So there is one I want you to find. Energy. What is the unit for energy? Can you find it? I'll give you the formula. I'll allow you to find. Energy is constant distance. Better find it.
Asking.
Find energy is lost and distance. Find it.
Asking. Asking.
No, Pastor, hey, you say something now.
Jude.
If you go back to pressure, either you use those parameters, if you solve it, those what I gave you, or you use Pascal, or you use what? Pascal. Are you following now? You know that work done can be joules per second. Thank you for reminding me that. Work done, let me show you. Should I play here? I should play here, huh? Have you taken this? See, look. Work done. What I'll do is that I will stop after energy because the more and more valuable factor issue, it will lead to the law of diminishing return. That is economics. Law of what? Diminishing return. So I'm going to give you the capacity that your brain can handle. Too much information leads to loss of information. So we will stop after energy, okay? So now work done. Do you know that work done, what is the call it? Power, not work done. Power is work done over what? Time. Work done can be measured in joules. Can be measured in what?
Joules.
If you are a friend of physics, you will find sometimes they'll say the work done is 30 joules. Yeah. Are you there now? So work done can be measured in joules. Now they are dividing these joules over seconds. What may happen to it? Joules per second. So if you see this, I can also give the answer. Are you going to be energy? Give me the answer. Let me see.
Joules.
Okay, what do I say? Work done, if you're a friend of physics, then I say the work done is 30 joules. Correct. Work done, the work, yes? Work done can be measured in joules. So I can say the work done is 20 joules, 30 joules. Are you following that? Now the formula is work done over time, which is joules per second. Called joules per second. Like joules times by second plus the power of minus 1. I solve for energy, everybody. Solve for energy.
Energy will be joules.
What? But he said energy will be joules. Okay, let me solve it. Let's find some of these units I will say. Energy is force times what?
Distance.
I will solve momentum. Check your note. Is momentum there?
Yeah.
You'll go over sometimes. Energy is force times what? Distance. Are you there now? What's the unit for force again? Newton. What's the unit for distance? So this can be Newton meter. Energy can be Newton meter. Which is almost the same thing with one of those one. Are you following? Now you can also say that energy, let's kind of constant. Okay, come on. Energy can also be force times distance again. What's the formula? What's the unit for force? Kilogram, meter, per second squared times by meters. Are you following? 1 plus 1 is what? 1 plus 1 is what? 2. So this can also be the unit for energy. So that's where we'll stop for today's class. Any question? Solve for momentum. And we solve for
Master is
we
velocity.
solve for it. Let's pray. I'm blessed. Any question before we pray? Yes. Power can be measured in watts. What we're trying to do is that if there's certain question for you, they'll look for one that those questions that will confuse you. Power is measured in watts. And then power is also measured in joules per second just about minus 1. They know those things. And then they can say, which of these is the unit of power? Watts, joules per second just about minus 2. And then they give you, where is it again? They give you any of those will solve this. And they will give you one that's wrong. They'll say option A, I. Option B, I. Are you following now? So you cannot pick the correct answer from those. Are you following now? Yeah. Alright, any other question? Yes. Which one? This one? Odd one. This is work done over time. Power is work done over time. Joules over seconds. Any other question? I'm blessed. I'm a blessing. I'm blessed. I'm a blessing.
I'm a blessing.
My resolve.
My resolve.
My resolve.
My resolve.
Will make you go banana.
Will make you go banana.
Look at me.
Look at me.
I'm a success.
I'm a success.
Look at me.
Look at me.
I'm a success.
I'm a success. I refuse to fail.
I refuse to fail.
I refuse to fail.
Now my head is up. I refuse to fail.
Now I have resolved. I refuse to fail.
I refuse to be defeated.
I refuse to be defeated.
I am blessed.
I'm blessed.
I'm a blessing.
I'm a blessing.
I'm the light of the world.
I'm the light of the world.
I'm the light of the